Good afternoon, wherever you may be in your day. Thank you, as always, for choosing to make chemistry part of your day. This lecture is going to be, I don't know, probably a little bit drier than usual. This is the list of polyatomic ions we'll use in class. And I rarely do this, and I try very hard not to do this, but this is one of these cases where you're just going to have to memorize it. Let's just start with what is a polyatomic ion. Polyatomic ion is, as the name implies, it is more than one atom together with a charge. So two or more atoms bonded together covalently forming a charged particle. Most of these are anions, and to prove that point, all of the cations you have to memorize right here. I can even leave off the S. We have one cation we'll use. It'll be ammonium. It does cause a little, bit of confusion. We do have to double check whenever nitrogen is at the beginning of a compound. There's a couple different things that could be going on there. So just keep that in mind. But NH4, we always want to look for that at the front of a molecule. It'll always be at the beginning when it's written. And that's a cation, meaning positive charge, and it is ammonium. This is the one case where it's not a metal. Cations done, let's move to anions, and there's lots and lots of polyatomic anions. We're going to do a sampling of the ones that are most common. Why do we make you guys do this? Well, the Earth's atmosphere is 20% oxygen, and the rest of the atmosphere is not very reactive, so pretty much anything that bubbles to the Earth's surface eventually gets oxygen stuck on it. And you'll notice the vast majority of these polyatomic ions are some combination of oxygen. Okay, so these are very, very common things, whether it's biologically, environmentally, even synthetically. All right, so a couple of these are really just memorized. Acetate, C2H3O2 with a -1 charge. It is important to memorize the size of the charge, whether it's -1 or -2 or -3 or +1, that does matter. So we need to know C2H3O2- is acetate. We need to know that Cn- is cyanide. We need to know OH- is hydroxide, Cr2O72- is dichromate. The halogens are a little funny in that they form a whole sequence of oxygen compounds. So you can see the nice thing here, though, is the charges are all the same, and they're all the same we would predict normally for the halogen family. They form almost 100% of the time -1 charges, and all their polyatomic ions are also -1, so that helps a little bit. But differing amounts of oxygen. Everything else is the same. 1 chlorine, 1 charge, oxygen, 1, 2, 3, 4. So normally the one with the most oxygens, we end with an ATE. But since there's more than 2 options, we can't just do ATE and ITE, or the 8 and the ite. We gotta go further. So hyper means like lots of activity. Hypo means low energy. So low amounts of oxygen. So least amount we can have is 1. Then we go into our normal ite ending. Then we go into our normal 8 ending. And then we need like a super 8, if you will. So we're going to call this perchlorate. So we put a per in front. If you want to think 4-chlorate, like 4 oxygens per, if that helps, great. And this would be the same then. So if we had BrO2-, this would become bromite. Or BrO3- would become bromate. Sorry about that. A little bit of a speaking impediment here. All right, so let's get into this 8 and 8 idea. Like I said before, a lot of these polyatomics have oxygen. So whatever oxygen is attached with, the root of that word becomes the front. So if it's attached to chromium, we put chrome out front. If it's attached to carbon, we put carb out front. If it's attached to nitrogen, we put nitra out front. If it's attached to phosphorus, we put phos. If it's sulfur, we put sulf. So we take the root of the word, put it out front, if it's attached to oxygen. And then we put 8 or ite as an ending. If it's got the maximum number of oxygens, we put 8. If it has 1 less than the maximum, we put ite. Now, the atoms at the top of the periodic table are very small, so they can hold less oxygens. Once we get past that top row of the P block of the main group, they're bigger and they can hold 4 oxygens. So, really the outliers are the top, so carbon and nitrogen. We're going to have 3 oxygens will be an 8 ending, 2 oxygens will be an ite ending. So CO3-2- is carbonate. NO3- is nitrate. NO2-, 1 less, is going to be nitrite. If you're thinking Han Solo got dipped in carbonite, that would be CO2-2-, although not common. And that would be those two. So you'll also notice if you look at all of the elements in the columns, they go even, odd, even, odd. All of the elements that are even have an even charge, -2. And all the ones that are odd have an odd charge, which could be -1 or -3. Although phosphorus is really the only -3 you have to worry about. So if it's odd, it's -1 unless it's phosphorus. If it's even, it's always -2. So that should help a little bit with determining charge. Yeah, so -2, -1. You can also see a trend. -3, -2, -1 for the charge, and then it follows the rest of the way down the periodic table. Okay, so once we get past this top row where it's 3 and 2, we can go 4 and 3. Now a maximum of 4 oxygens becomes 8, as in PO4 would be phosphate, SO4 would be sulfate, and 3 oxygens gets the ITE ending. So PO3 is phosphite, SO3 is sulfite. And then the charges follow the family trends, the general trend of counting out 0, -1, -2, -3. So in many ways, these are easier to do. And we don't use arsenate, but one of the reasons arsenic is toxic is it mimics phosphorus in the body. So phosphorus and phosphate and ATP in your DNA. It incorporates arsenate in your ATP in your DNA, and that causes, toxicity problems, biological problems. So that's part of the reason for the toxicity there, is that mimicking, where it's not the same, but it's similar. All right, anybody I missed? Chromium works the same way. It's element number 24, and it's down on the periodic table, so it means it can hold 4 oxygens. It's an even number, so it's 4, 2 minus, and that's chromate. So some of that works. And you can always just make flashcards and memorize. And one last joy to this is if it has a charge larger than 1, we can add things to it and still leave it with a charge. So for example, sulfate has a -2 charge. If we add a charged hydrogen, which has a +1 charge to it, 1 positive and 2 negatives leaves us with 1 negative, still a polyatomic ion. So that has to have a different name because it's going to have different chemistry than SO4 2 minus. So if this is sulfate and we put a hydrogen in front, the naming's super easy, hydrogen sulfate. So if we take PO3 3 minus, you might remember that is phosphite. Phosphite plus hydrogen makes hydrogen phosphite. Still -2 charge, we can throw another hydrogen on there. Woohoo! So that, again, different chemical, different property, different charge, and needs a different name. So 2 hydrogens becomes dihydrogen phosphite. And there you go. If you got all those names down, good for you. I suggest flashcards on this. Have a wonderful day, and thank you for your time and energy.